Have you ever really stopped to think about how you know the world around you is, well, real? I mean, it seems so obvious. You just open your eyes and there it is. But what if I told you that what you're experiencing isn't the world itself, but a super fast, incredibly complex reconstruction happening inside your own head? Okay, let's dive into that amazing journey, from raw information to conscious reality, starting at the very beginning with sensation. So, let's set the scene. Imagine you're walking down a dark street. It's foggy, and suddenly, you see some movement out of the corner of your eye. Your heart's probably pounding a little, right? In those few seconds, your brain is working like crazy, taking these little fragments of light and shadow and trying to solve a puzzle that could be, well, pretty high stakes. This is the challenge our brain faces every single moment of every day. So yeah, that's the big question we're tackling. How does that jumble of sensory info, that flicker of movement, that vague outline, turn into something meaningful, something you can actually name and react to? It feels instant, like magic, but it's an incredible feat your brain pulls off without you even thinking about it. Okay, so to really get this, we've got to start at square one. Before your brain can interpret anything, it first has to get the data. And that initial stage, that's what we call sensation. It's the most basic connection between the outside world and your inner world. Sensation, at its core, is all about data collection. It's the physical energy from the world around you, light waves, sound waves, you name it, getting picked up by your sensory receptors. But at this stage, there's no meaning attached at all. It's just raw, totally unprocessed information. Seeing is not the same as perceiving, not yet. And this is where it gets really wild. This slide shows the huge gap between reality and what our brain actually has to work with. So you've got the tree out there in the world. That's the distal stimulus. But what your senses actually register, the proximal stimulus, is a tiny, two-dimensional, and get this, upside-down image of that tree on your retina. So your brain's first job is to take that messy, flipped data and somehow turn it back into the stable 3D world we all experience. Okay, so the brain's got this messy upside-down data. What does it do? Well, one way it works is by acting like a detective, piecing together clues from the ground up without any preconceived notions. We call this bottom-up processing. Think about it like this. You're trying to put together a jigsaw puzzle, but you have absolutely no picture on the box to guide you. All you can do is look at the individual pieces, the shapes, the colors, the edges, and start fitting them together. That's bottom-up processing. It's completely driven by the data coming in from your senses. So, how does it find those puzzle pieces in the first place? It uses these incredible little things called feature detectors. These are basically hyper-specialized neurons in your brain. Each one is tuned to fire only when it detects a very specific, very simple element, like a horizontal line, a 90-degree angle, or something moving from left to right. And here's a brilliant example of this in action. A frog's whole life depends on catching insects, right? So its visual system literally evolved to have cells that are dedicated to detecting one thing, small, dark, moving dot. They're basically bug detectors. It's a perfect real-world case of how bottom-up processing starts with the absolute basics. But wait, that can't be the whole story. If our brains only worked that way from the bottom up, we'd be incredibly slow to figure anything out. So our brain has a trick up its sleeve. It takes massive shortcuts by using what it already knows to make some really smart guesses. Let's see how that works. All right, do me a favor. Just read this phrase out loud. Go on. Go on. Paris in the spring. Simple enough, yeah? Now, go back and look again. Really look. See it? There are two these. But chances are your brain just edited it out. It skipped right over it. Why? Because your past experiences, all the times you've heard that phrase, told your brain what should be there. And that expectation was so strong, it actually overrode the sensory data your eyes were sending. Wild, right? And that, right there, is top-down processing. It's when your knowledge, your memories, your expectations, all the stuff already in your head, shapes how you interpret the sensory info coming in. It's what lets you read terrible handwriting or understand a friend in a loud room. Your brain is a know-it-all, in a good way, using context to fill in the blanks. So we've got sensation, which is the raw data, and then we have perception, this incredible process where our brain uses both bottom-up and top-down tricks to create meaning. But what happens when that system breaks? Well, a rare neurological condition makes the distinction between simply seeing and truly perceiving absolutely crystal clear. A person with visual agnosia has perfectly healthy eyes. Their sensation is completely intact. Light hits the retina, signals get sent to the brain, all of that works fine. But because of damage in the brain, that interpretation part, the next step in the process, it's broken. They can see, but they can't perceive. Just try to imagine what this is like. A patient can describe the features of a face, they can tell you the color of the eyes, the shape of the nose, but they can't put those features together to recognize who it is, not even their own spouse. Sensation is giving them all the puzzle pieces, but without perception, they just can't solve the puzzle.
And that leaves us with a pretty mind-bending final thought. If your brain is constantly guessing, filling in blanks, and using your past to build your present reality, well, where does the raw data end and your personal interpretation begin? It really makes you wonder just how differently two people can experience the exact same thing.